Beneath nearly 2 miles of solid ice in Greenland, scientists have discovered something that completely changes everything we thought we knew about our planet's history. They found ancient forests, perfectly preserved DNA from creatures that walked the Earth 2 million years ago, and evidence that flips our entire understanding of climate change on its head. This discovery is so significant that it's forcing scientists to rewrite textbooks and rethink humanity's future, because what they found under all that ice proves that Greenland wasn't always frozen, and the implications of that are absolutely terrifying. For decades, scientists believed they understood Greenland. It's the world's largest island, and about 80% of it is covered by an ice sheet so massive that if it all melted, it would raise global sea levels by over 20 feet. The conventional wisdom was simple. Greenland has been frozen for millions of years, a permanent fixture of ice that's been there since long before humans walked the Earth. But in 2019, a team of researchers drilling deep into northwestern Greenland's ice made a discovery that would shatter that assumption. The scientists were extracting ice cores, which are basically long cylinders of ice drilled from deep within glaciers. These cores are like time machines. Each layer of ice represents a different period in Earth's history, and by studying them, scientists can learn about ancient climates, temperatures, and atmospheric conditions. But this time, they found something completely unexpected. At the bottom of their ice core, nearly 2 miles down, they discovered something that shouldn't have been there: soil. And not just any soil, but soil filled with perfectly preserved plant material. When they examined it more closely, they found fossilized twigs, leaves, and moss. The preservation was so good that the cellular structure of the plants was still intact. It was as if someone had taken a snapshot of an ancient forest and frozen it in time. The team was stunned because, according to everything they knew, this was impossible. If Greenland had been continuously frozen for millions of years, there shouldn't be any plant fossils under the ice. And yet here they were, staring at undeniable proof that trees and vegetation once grew where there's now nothing but ice for thousands of miles. The discovery raised an obvious question. If there were forests here, when did they exist and what happened to them? The answers would come from one of the most cutting-edge techniques in modern science: ancient DNA analysis. The research team carefully transported their samples to laboratories around the world, where geneticists began the painstaking process of extracting and analyzing ancient DNA from the frozen soil. This is incredibly difficult work. DNA degrades over time, and finding intact genetic material from millions of years ago is like searching for a needle in a haystack. But the Greenland samples were so well preserved by the ice that they yielded an unprecedented treasure trove of genetic information. In 2022, the results were published, and they were absolutely mind-blowing. The DNA they recovered was 2 million years old, making it the oldest DNA ever discovered, shattering the previous record by over 1 million years. But what really shocked the scientific community wasn't just the age of the DNA, it was what the DNA revealed about the creatures and plants that once lived in Greenland. The genetic material showed evidence of an entire ecosystem that thrived in Greenland when it was ice-free. There were mastodons, those enormous elephant-like creatures that roamed North America during the Ice Age. There were reindeer, lemmings, and geese. The DNA also revealed a diverse array of plant life: poplar trees, birch trees, and various shrubs and mosses. This wasn't some barren tundra barely clinging to life. This was a thriving green landscape teeming with animals and vegetation. The scientists could barely believe what they were seeing. Greenland, this frozen wasteland, had once been covered in forests. It had been warm enough for trees to grow and for large mammals to roam freely. The implications were staggering, because if Greenland had been ice-free within the last 2 million years, it meant the ice sheet was far more vulnerable to temperature changes than anyone had previously thought. But there was another question that needed answering. Exactly when was Greenland ice-free, and what caused it to freeze again?
Dating the samples precisely was crucial to understanding what happened, so the research team used multiple dating techniques to pinpoint when this ancient ecosystem existed. What they found was both fascinating and deeply concerning. The evidence suggested that Greenland had been largely ice-free somewhere between 450,000 and 800,000 years ago, during a period known as the marine isotope stage 11. Now, you might be thinking, okay, so it was warm a long time ago, what's the big deal? Here's the big deal. During that period, global temperatures were only slightly warmer than they are today, roughly 1 to 2 degrees warmer. That's it. Just a couple of degrees difference, and Greenland went from being a frozen ice sheet to a green, forested landscape. Let that sink in. The temperature difference between a frozen Greenland and a green Greenland is about the same as the amount of warming we're experiencing right now due to climate change. This discovery completely changed scientists' understanding of how sensitive the Greenland ice sheet is to temperature changes. Previously, many researchers believed the ice sheet was relatively stable and would take thousands of years to melt, even with significant warming. But the evidence from these ancient samples proved otherwise. The ice sheet had melted before, relatively recently in geological terms, and it had melted under conditions very similar to what we're experiencing today. The research also revealed another critical piece of information. When Greenland was ice-free, sea levels were significantly higher than they are today. The melting of the Greenland ice sheet alone contributed to sea level rise of up to 20 feet. That might not sound like much, but consider this. Over 40% of the world's population lives within 60 miles of a coast. A 20-foot rise in sea levels would be catastrophic, flooding major cities like New York, London, Tokyo, Shanghai, and Miami. Entire island nations would disappear. Hundreds of millions of people would be displaced. But the story doesn't end there, because the discovery of this ancient ecosystem raised even more questions about how ice sheets form, melt, and reform over time. As scientists continued to study the cores and the DNA evidence, they began to piece together a more complete picture of what happened to Greenland over the past 2 million years. What they discovered was a cycle that's both natural and terrifying in its implications for our current situation. The evidence showed that Greenland's ice sheet had gone through multiple cycles of growth and retreat. During warm periods, the ice would melt away, allowing forests and wildlife to flourish. Then, when temperatures dropped again, the ice would slowly rebuild, burying everything beneath it. This cycle had repeated itself multiple times throughout Earth's history, driven by natural variations in the planet's orbit and other factors. But here's where things get really interesting and concerning. The researchers found that once the ice sheet starts melting, the process can accelerate rapidly. This is because of several feedback loops that kick in. First, there's the albedo effect. Ice and snow are white and reflect sunlight back into space, keeping the surface cool. But as the ice melts and exposes darker soil and rock underneath, those darker surfaces absorb more heat, which causes even more melting. It's a vicious cycle. Second, as the ice sheet melts, it creates lakes and rivers of meltwater on its surface. This water is warmer than the ice and can carve channels and tunnels through the glacier, weakening its structure and accelerating the melting process. Scientists have observed this happening in real time in Greenland today. Massive lakes form on the surface during summer months, and sometimes they drain catastrophically, carving huge channels through the ice in the matter of hours.
Third, as the ice sheet loses mass, it becomes thinner, which exposes more of its surface to warmer air temperatures. The thinner the ice gets, the faster it melts. It's another feedback loop that can turn a gradual melting process into a rapid collapse. The ancient DNA discovery proved that all of these processes had happened before in Greenland's history, and they could happen again. In fact, they're already beginning to happen. Modern measurements show that Greenland is losing ice at an accelerating rate. In the 1990s, Greenland was losing about 50 billion tons of ice per year. By 2025, that number had increased to over 280 billion tons per year. That's more than a 5-fold increase in just 3 decades. The implications of the Greenland discovery extend far beyond just understanding the past. They're a warning about our future. Climate scientists have been studying the data from these ancient samples and combining it with modern climate models to predict what might happen to Greenland in the coming decades and centuries, and the results are sobering. Current projections suggest that if global temperatures continue to rise at their current rate, we could see significant melting of the Greenland ice sheet within this century. Some models predict that we could lose 50% or more of Greenland's ice by 2100, which would contribute several feet to global sea level rise on top of the rise from thermal expansion of the oceans and melting of other glaciers. But here's the truly alarming part. The ancient DNA evidence shows that once the melting process reaches a certain point, it becomes essentially irreversible on human timescales. Even if we were to somehow magically stop all greenhouse gas emissions tomorrow, the ice sheet would continue to melt for decades or even centuries because of the momentum already built into the system. The feedback loops we discussed earlier mean that the melting process has its own inertia. Scientists refer to this as a tipping point, and the evidence from ancient Greenland suggests we may be approaching one. The exact location of that tipping point is still debated. Some researchers think we may have already passed it, while others believe we still have a narrow window to prevent the worst outcomes. But what everyone agrees on is that Greenland's ice sheet is far more vulnerable than we thought just a decade ago. The discovery has also changed how scientists think about other ice sheets, particularly Antarctica. If Greenland could melt under relatively modest warming, what does that mean for Antarctica, which holds enough ice to raise sea levels by over 200 feet if it all melted? The answer is that Antarctica is likely more vulnerable than previously thought as well. Researchers are now looking for similar evidence of ancient ecosystems beneath Antarctic ice to better understand its history and vulnerability. The Greenland discovery has injected new urgency into climate research and policy discussions around the world. Scientists are now racing to gather as much data as possible from Greenland and other ice sheets before they melt further. Multiple research stations have been established across Greenland, equipped with advanced sensors and drilling equipment. Satellites continuously monitor the ice sheet's mass and movement, providing real-time data on how quickly it's changing. One of the most ambitious projects currently underway is an effort to drill even deeper into the Greenland ice sheet to find older samples that might reveal even more about Earth's climate history. Researchers hope to find ice and organic material that's 3 or even 4 million years old, which would tell us about periods in Earth's history when carbon dioxide levels were similar to today's levels. This information could help refine predictions about what's coming in our own future. Meanwhile, policymakers are grappling with what to do about the information these discoveries have revealed. The Paris Agreement, signed in 2015, committed nations to limiting global warming to well below 2 degrees Celsius above pre-industrial levels, with an aspiration to limit it to 1.5 degrees. The Greenland discoveries have underscored just how critical these targets are. Even seemingly small amounts of warming can have dramatic and long-lasting consequences. Some countries are taking aggressive action to reduce their carbon emissions and transition to renewable energy. Others are moving more slowly, hampered by political divisions and the enormous economic challenges of transforming entire energy systems. The debate over climate policy has become one of the defining issues of our time, and the stakes couldn't be higher. What makes the Greenland discovery so powerful is that it's not based on computer models or projections. It's hard, physical evidence of what has actually happened on Earth before. The DNA doesn't lie. The fossils don't lie. Greenland was green, and then it froze, and the ice we see today is not some permanent feature that's been there since the dawn of time. It's geologically recent, and it's vulnerable. This discovery has fundamentally changed the conversation about climate change in the scientific community. Before, there was always some uncertainty about how ice sheets would respond to warming. Scientists had to rely on computer models and their best estimates. But now, we have a real-world example of what happened the last time Earth's climate was similar to what we're experiencing today. We know that Greenland melted. We know how much the sea levels rose. We know that ecosystems completely transformed. And we know that it happened relatively quickly once certain temperature thresholds were crossed. The ancient forests of Greenland are a time capsule, but they're also a warning label. What do you think we should be doing about the ice sheet melting? Drop your thoughts below, and if you're not already subscribed, hit that subscribe button and turn on notifications so you never miss our next deep dive into the stories that are shaping our world.